Hello, my name is Karen Gala. I'm the Executive Director of the Council on Food, Agricultural, and Resource Economics, and we're very pleased today to have I think the third webinar in our webinar series, summer webinar series, on pollinator economics. We have a great lineup for you today, but before we proceed, I just wanted to tell you that if you're interested in learning more about agricultural and applied economics, please feel free to view our webpage. We have a lot of good publications and reports there. The vision for the Council is to catalyze informed decisions through applied economics. We are happy today to partner with the USDA Economist Group, and I'll turn it over to Chris Burns, who is the program person for that group, to tell you a little bit more about that group.
Great, thank you, Karen. My name is Chris Burns. I'm a research economist at the USDA Economic Research Service, and I'm also the co-vice president of programming for the USDA Economist Group. The mission of the USDA Economist Group is to be a responsible, independent advocate for economists at the U.S. Department of Agriculture, as well as the Washington community, the agricultural economics profession, and society at large. In general, we are trying to promote a sense of community among economists interested in USDA policies and programs. You can check out our webpage, usdaeconomist.org, where you can see other programs that we have sponsored with CFAIR, and if you are interested, you can become a member of our organization to learn more about us. At this time, I'm going to turn it over to our moderator for this webinar, Val Zolstini. He's the president and CEO of the Pollinator Partnership.
Chris, thank you very much, and good afternoon, everybody, and to those in the Pacific time zone, good morning. Today we're going to hear from a couple of really great panelists who are going to talk about pollinator economics in the United States, demands, costs, and logistics. But before I turn it over to our speakers, let me tell you a little bit about the Pollinator Partnership. You can find information about my organization at www.pollinator.org. We are a nonprofit organization focused on the promotion and protection of all pollinating animals, from bees to butterflies to bats, birds, beetles, and others that pollinate, and we operate throughout the North American landscape. I'm a former USDA official. I'm a Californian. I've worked a lot with farmers and ranchers over the course of my career, and it's really an honor for me to moderate today's conversation. We're going to hear from Brittany Goodrich from Auburn University and Peyton Ferrier from the USDA Economic Research Service, and they'll introduce themselves. But I would encourage all of the folks listening in to today's webinar, which by the way is being recorded and can be found later at the CFAIR website, to submit questions, and you can do that looking at the screen right in front of you. There'll be a little chat box there for you to submit your questions, and we'll go through those following both of the presentations. So with that said, Brittany, I will turn it over to you for introductions and for your slides.
All right, thank you, Val. My name is Brittany Goodrich. I'm an assistant professor in the Department of Agricultural Economics and Rural Sociology at Auburn University here in Alabama. And Peyton, are you introducing yourself now as well?
Sure. I'm Peyton Ferrier. I'm an economist with the Markets and Trade Economics Division at the Economic Research Service of the USDA.
All right, so I will be talking today specifically about the almond pollination market in California, and then Peyton will go sort of a more broad view of pollination markets throughout the US. And so this information that I'm sharing today comes from my dissertation research, where I recently did that out in California at University of California, Davis. And I'm now at Auburn University, but I'm still doing bee research here, just working with the Alabama beekeepers and others here at Auburn. So to start, just to give some context, California produces most of the world's almonds. So it's pretty much any almonds that you eat are coming from California. And because it's such a big almond producing area, it actually requires almost 70% of honeybee colonies throughout the US for its pollination needs. So there's about 1 million almond acres in California currently, and that requires about 2 million honeybee colonies because almonds need to be cross-pollinated. So this is really the largest single pollination event in the world. So it's pretty huge, and it's, around $3 million in pollination contracts are exchanged between beekeepers and almond growers each year. So when we think about pollination services, a lot of times we don't think about how commercial it is. So this is a really big industry. A lot of commercial beekeepers in the US are actually migratory, and they transport hives throughout the United States on these big semi-trucks that are full of around 400 to 450 hives. So just to give you an idea, for 2017 almond pollination, that required over 4,300 truckloads of hives coming into California. So what I want to talk about is a few issues where honeybee colony health is really influenced by almond pollination, but also almond production completely requires honeybee colonies for its production every year. So honeybee colony health is influenced by almond pollination because these colonies are being shipped across the US. They're being shipped into a relatively close proximity to one another, and that can facilitate the spread of pests and diseases. And also, anytime you transport colonies into an agricultural area, you have potential for pesticide exposure. On the other hand, almond pollination is, providing beekeepers with about 1/3 of their revenues on average in the US. So it can really help out beekeepers, give them some working capital to improve their colony health throughout the rest of the year. But then, like I said, again, almond production is completely dependent on the health of managed honeybee colonies. So I'm going to describe a little more in detail about each one of these points. So first, I'm going to talk specifically about honeybee colony shipments for almond pollination. So since we require about 70% of the US honeybee colonies, the colonies for almond pollination are coming from all over the US. So this map is a heat map showing where where the honeybee colonies are coming from. And you see the upper Midwest states, North Dakota, South Dakota, Montana, supply a lot of colonies for almond pollination, as well as others in the Pacific Northwest. In more recent years, states in the Southeast, like Texas, Louisiana, Florida, have started supplying more and more colonies. So these are areas that are relatively have high transportation costs to get to California for almond pollination, but also there are some opportunity costs there because beekeepers in those areas can produce honey at the same time that almonds are blooming. So this gives you an idea of where the almond acreage is in California and where those colony shipments are going to. So on the left-hand side, you see a map of California where it's a heat map of the bearing almond acreage. And so you can see the top 3 counties there in terms of acreage are Kern, Fresno, and Stanislaus. And then you can see on the right-hand side the number of colonies that are being shipped into each California county. And you can see that it almost perfectly matches up, that most of the colonies are being shipped into these counties that are heavily almond producing areas. And so I thought it was interesting to look at how concentrated these areas are in terms of the number of colonies. So what I did was I just did a simple calculation of the number of colonies shipped in to the California county divided by its square miles. And so these are going to be lower bound estimates because I'm not considering any of the colonies that stayed in California year round, and I'm factoring in the cities as well that aren't ag areas. So you have Stanislaus, Madera, and Merced counties all of them have upwards of 80 colonies per square mile, which is pretty significant given that bees typically forage, up to 2 miles from their hive. So this is really, these colony concentrations during almond bloom are really facilitating cross-colony interactions and possibly spreading pests and diseases. And this gives you a visual look at what this looks like during almond pollination. So you can see here the hives where the beekeepers are walking through. That's about roughly 100 or so hives. And then you can see that the entire background is dotted in double stacked pallets of hives. And these are just waiting to be placed into almond orchards. So this is really a lot of colonies that are being mixed together from all over the US. Okay, so then we need to switch gears and talk about pesticides and honeybees. So like I said, anytime you have a honeybee colony in an agricultural area, there's likely, going to be some exposure to pesticides. So there's a couple of avenues that this can happen. The first one is in that crop that's being pollinated. So if the honeybee colony is in almonds and the almond grower sprays a pesticide, that's one avenue of exposure. The other one is going to be unintentional, where the bees may be foraging either for honey production or on some other crop that they're not pollinating and get exposed to pesticides. So the first type is typically minimized by pollination agreements. So growers and beekeepers are going to be talking about the pesticides being sprayed when the bees are in there for pollination services. And the second one is problematic because it's, accidental and not really, it's going to be harder to take care of. So the almond industry has done a really good job to try and mitigate some of this exposure by putting out best management practices for almond growers to follow while bees are in the orchard. And so a colleague of mine, Jenny Duran at UC Berkeley, we have been looking at pesticide applications in almonds during bloom, just to sort of see what's been going on historically with pesticides. So you can see here that we've picked out a subset of pesticides and looked only during February 15th to March 15th to look and see what's happening with spraying in almonds. And so you can see that almond growers have done a really good job of not spraying a lot of toxic and acutely toxic pesticides, especially in recent years during almond bloom when they know bees are going to be there. But then the sublethal toxicity pesticides, which may or may not be labeled as being harmful to bees, they're still being sprayed quite often. And so one other way to look at this is whether they contain a precautionary statement or they don't contain a precautionary statement that these are harmful for bees. So you can see this is reassuring that when there is a precautionary statement, almond growers are not typically spraying a whole lot of pesticides during almond bloom. However, if there is no precautionary statement about being harmful to bees, they're spraying more. So it's reassuring in that the labels are working, but then we have to be extra careful to make sure we're properly labeling everything, even if it has just a sublethal effect. And I did want to highlight that pesticide concern is more than just at almond bloom. So this graph is a histogram of honeybee colony shipments into California, and the highlighted pink line is almond bloom, and this goes from 2013 to 2016. And so you can see that honeybee colonies start arriving in California for almond bloom starting in October, and they're consistently arriving up until bloom. And so there's many hives in the Central Valley before almond bloom that have the potential to be exposed not only from almond applications, but in other crops as well. And it seems like beekeepers are arriving later and later to California, and maybe that's an adjustment to pesticide risks, or it may be something else. But So it seems like beekeepers could be adjusting, but then there's also the fact about the other crops that are being sprayed either during almond bloom or before or immediately after almond bloom that could potentially impact bee health as well. Okay, so I also wanted to highlight, since almond production is completely reliant on honeybee colonies, and we're utilizing 70% of the colonies already, sort of where do we go from here in the US? So as you can see, almond acreage and almond pollination fees have been pretty steadily increasing over the last couple of decades. So if we're already utilizing all of those colonies, what do we do from now on? So what I wanted to do was look at approximately how many colonies are available that were not being utilized for almond pollination. So I looked at this for 2016. And so you can see with the heat map here that the southeastern area of the US seems to have a lot of potential. Areas in Florida, Georgia, Louisiana, Texas, they still have a lot of colonies that aren't participating in almond pollination that could be. But again, these areas are higher cost areas in terms of transporting colonies to almonds in California. So for the 2019 demand in 2016, the almond acreage report estimated that there'd be about 81,000 additional colonies or acres bearing by 2019, which would mean about 148,000 additional colonies that would be needed for almond pollination. So I estimated that about 644,000 colonies didn't participate in 2016 almond pollination. So that's about 23% of non-participating colonies. So it's a pretty significant amount. And so the real question is how long will the trend of increasing almond acreage continue? And that's sort of unknown. In 2017, there were about 22,700 acres planted. So those will come to be bearing in a few years, and so then bee colonies will be needed for those as well. So where will the additional colonies come from? So will more beekeeping operations participate in almond pollination? Probably. But higher fees may be necessary to cover, higher costs of transportation or opportunity costs from honey production. The next question is, will already participating beekeepers expand their operation? And this is a maybe, in my opinion. So forage is a limiting factor for beekeeping operations. That's been found from another study out of UC Davis. And so, beekeeping operations can't really easily just expand. They need to have more land so that they don't have to feed their colonies. So this is problematic. And then also high colony loss rates make expanding difficult and risky for beekeeping operations. So I anticipate that a lot higher fees may be needed to incentivize expansion of current commercial beekeeping operations. Okay, and that is all I have. So yeah, feel free to send me any questions or ask questions during the time. Otherwise, I will turn it over to Peyton.
Hi there. This presentation, Economic Effects and Responses to Changes in Honeybee Health, it comes from an economic research report at the USDA. It's written in conjunction with Randy Rucker, Wally Thurman, and Mike Burgett, and you can find it right now on the ERS website. So what did our report find? Well, we have four main findings. First, despite elevated loss rates for honeybee colonies, their numbers are stable. And I'll get into the details of this in a moment. Pollination service fees are now the biggest source of beekeeper revenue. In 2016, they slightly edged out honey as a share of beekeeper revenue. Almonds are driving pollination service markets in a number of regards. And finally, pollination service costs for most crops are a small share of farm and retail food costs. So we found that pollination service costs, aside from almonds, typically are less than 5% of farm costs and less than 1% of retail food costs. Okay. So as a little bit of background on beekeeping, beekeepers raise honeybees as livestock for pollination service fees. They sell the honey that the bees make over the course of the year. And then they also have sales of beeswax, and they also sell queens, nukes, and packages, and those are basically breeding stock that they can sell to other beekeepers. Commercial beekeepers are often migratory, as Brittany went through. In addition to moving their colonies to rent them for pollination service fees, they also move their colonies to pursue productive forage grounds for honey. And this involves sort of a well-traveled path over the course of a year. Honeybee colonies can be replaced via splitting, and splitting is seasonal. It typically occurs once it warms up, typically in April, May. Some areas it might be a little bit later than that if the spring comes later, since the bees have to leave the colonies and the weather needs to be warm when they do that. Data on colony loss and pollination service fees that I'm going to go through in a moment is relatively new. So in addition to beekeeper surveys, the National Agricultural Statistics Service in 2015 started collecting national level data on pollination service fees, and also quarterly loss rates for colonies and colony count, or colony populations at the state level. Prior to that, the Bee Informed Partnership has collected, and they're still collecting this data since 2007. And there's various measures for the number of colonies, the total number of colonies in the U.S. Winter loss rates for honeybee colonies are thought to have historically been about 15%. And starting in 2006, with the identification of colony collapse disorder, again, the Bee Informed Partnership started doing surveys of colony loss, and that rate of winter loss has roughly doubled since then. Despite the elevated rates of loss, honeybee colonies are stable over the last 20 years or so. On this figure I'm showing you, the red dots represent the counts of colonies recorded in the 5-year Ag Census data, and the blue line shows you the National Honey Report data. Now, the National Honey Report data does not count colonies that do not produce honey, and there's also some methodal sort of detail issues with the count of colonies. But if you look at either data series, either the number of colonies is roughly stable over since 1996 or so, or if you think the Ag Census is more accurate, it might actually, the number of colonies might actually be increasing. Now, one thing we looked at in this report is the relationship between winter loss rates and the annual year-to-year change in the number of colonies. The concern is that a high winter loss rate will create some persistent reduction in the number of colonies available for pollination services. So we looked at whether there was a correlation between the winter loss rate and the year-to-year change in colonies. And if it's negative, then one would think that, okay, the beekeepers are really struggling to replace the colonies that they lost in the previous year. We didn't find that there was a significant negative correlation. And the figure I'm showing on this graph here, this uses the total U.S. number of colonies and the total U.S. loss rates. In the paper, we have a little bit of a more detailed analysis that also looks at the state level loss rates and the state level annual change in colony numbers, both with data in the National Honey Report, but also the more recent NASS colony loss report. So why aren't colony numbers falling? Well, in this the more recent NASS colony report data that's been available since 2015, at the state level, loss rates are positively correlated with addition rates. As I mentioned, the beekeepers can split colonies, and the addition rate includes splits, but it also includes colony purchases that beekeepers can do. For the most part, though, beekeepers replace colonies through splits. I think the number I've seen is 80, and we mentioned in the papers, over 80% of colony replacements are done with beekeepers splitting colonies. So what this data suggests is that as beekeepers lose colonies over the winter, then they're able, within the course of a year following that, to replace those colonies, which creates this positive correlation. And I mentioned loss rates are not significantly correlated with year-to-year changes in colony numbers. And that last figure shows some rates that I came up with. The loss rate was 14.7% in 2016, and the addition rate was 12.8%. So, shifting gears a little bit, looking at beekeeper revenue, compared to 1988, the share of revenue that beekeepers derive from pollination services has increased dramatically. In 1988, it was about 11%. In 2016, it was 41%. And that slightly edges out honey sales to make it the largest source of beekeeper revenue. And there's a little bit more of a breakdown in the report with regard to how much of that is explained by changes in honey prices and changes in honey yields, as opposed or just the growth of pollination service fees. So you can look for that there. Almonds drive pollination service markets. They make up 82% of all pollination service fees paid by farmers to beekeepers. And I break out the other main crops there in the key on the left. 61% of all colony rentals are done by almonds, and 52% of all acres paying pollination service fees are almonds. So that last figure is pretty significant because if you strip out the fact that almonds pay much higher pollination fees than other crops, you still find that almonds are renting the majority, are the biggest share of acreage paying pollination service fees. But almonds do pay far higher fees. And this graph shows you the changes in pollination service fees adjusted for inflation since 1987. This data is spelled out in the report. It comes from the Pacific Northwest Survey of Beekeepers. And this is the oldest continuous data set for pollination service fees. As I mentioned earlier, the National Agricultural Statistics Service only recently started collecting national data for pollination service fees. So prior to that, there's two regional data sets But this shows that almond pollination service fees started rising pretty dramatically in 2004, and that coincides with this big increase in almond acreage. Almond pollination service fees are higher. There's a lot of different explanations for why this is. Almonds bloom very early in the season when it's harder to get bees active and out into the fields. Their honey is reported to be bitter and poor quality. If you're bringing in lots and lots of bees from far distances, obviously the costs of getting them there are going to be higher. And then just the crop itself has very high pollination requirements coupled with big acreage growth. And this kind of retraces some of the themes that Brittany went over. In addition to acreage growing pretty steadily since 1986, you also had an increase in trees per acre in that time. I believe almonds are the #1 export crop for the state of California now. Despite sort of all the action that's happened in pollination service markets, they still represent a relatively manageable share of total farm costs. So almonds have, amongst the main crops purchasing pollination services, they represent the highest share of cost for almonds at slightly over 5%. But for other crops, the percentage seems to be far lower than 5%. And then it's less than 1% of retail food costs for those crops. And again, the report details how we got these numbers based on the available data. And these are some of the data sources that we used in our report: the NASS cost of pollination service, NASS cost of pollination data, crop production data, the NASS colony loss report data. Two of those reports, again, they only became available after 2015, as well as the Bee Informed data, ERS, fruit and vegetable data that includes farm shares of retail food prices. And I'm going to wrap it up on that note. Some of the reports from which this research is drawn are included below, and the last one is where you can find this online right now.
Peyton,
Great, thank you.
There is an opportunity for the webinar attendees to submit questions for either Peyton or Brittany based on their presentations. It certainly seems likely that given the demand for California almonds in Asia, particularly in China, these numbers of acres planted are going to continue to rise, and the demands on American commercial beekeepers will also continue to be high. Brittany, let me just ask you to kick things off. If I'm an almond grower in the Central Valley in California, how do I put your findings into action in order to maximize yields and do what I can to promote honeybee health on my acres?
Yeah, okay, thanks, Val. I would say relationships in this pollination market are of the utmost importance. As an almond grower, you definitely want a secure supply of strong, healthy colonies for almond pollination every year. So to do that, I think communication is really key. So communicate expectations with your beekeeper about colony strength requirement. Be very aware of the pesticide risks that are involved with pollinating almonds. So really communication, I think, is key here. And I think that as pollination fees, if they continue to rise and things get a little more sensitive in this area, I think it's important to do written contracts with your pollination services, especially in almonds. So I know a lot of beekeepers and almond growers want to do their contracts over a handshake. But I think as fees continue to rise, it gets really important to have a contract in writing so you know what's expected. And so when a dispute happens, you know, it can be settled legally if it comes to that.
Okay. Once again, there's an opportunity for members of the listening audience, the attendees, to submit questions, and we put up on the screen how to submit questions for me to ask our panelists here. Brittany, obviously, you know, these bees are not just in California, although some hives are focused exclusively on the almonds. There's typically a circuit that starts in the southern US and moves to California in the winter and then up the coast, and in some cases even across to the plain states to pollinate a variety of crops along the way. Are we seeing, you know, and Peyton, maybe this is a question for you to dig into, are the numbers of the secondary and tertiary crops, you know, getting any closer to almonds, or are they just kind of flat with regards to things like cherries and blueberries and Washington apples and the like?
Peyton, I think I'll let you handle that.
Yeah, one thing that's really striking within the data on pollination service fees is the seasonality of pollination service fees. Anything competing with almonds in California for colonies are going to pay the almond price for pollination services, and this includes early cherries, I believe plums, and also avocados. Later in the year, when the summer rolls around, things like apples, alfalfa pollination, the prices really drop off quite a bit. So when you'll hear kind of common discussions about the average pollination service cost having risen dramatically since 2000, you really have to separate out the almond effect because it's so dominant in swaying that average with that of other crops. And I would just add one thing. For cherries, they often distinguish, even within some of the older data sets, between early cherries and late cherries. And you'll see just this very noticeable difference in the bloom, because early cherries are, of course, competing with almonds, and they're paying that much higher fee. Right.
Brittany, what kinds of resources are involved with the additions of colonies to keep up with the loss? And, you know, this would include things like splitting. And does that affect the beekeepers and consequently the pollination service fees or product pricing that they receive?
So Peyton may be a better one to handle this, but I will say that there are colony strength requirements, at least in almond pollination, where you have to have a colony that's filled with, you know, 8 frames full of bees is the standard in almond pollination. So if beekeepers are splitting and they can't provide that 8-frame colony that the almond grower wants, that's going to have an effect on the pollination fee that they receive. So they'll probably end up getting a lower fee for those smaller colonies. Peyton, do you have anything to add to that? I know that you're working on a lot of this stuff with splitting and whatnot.
Yeah, what's the specific question, Val?
Let me go back up to it. Sorry, I'm kind of bouncing around here. The question is, what kind of resources are involved with the additions of colonies to keep up with the loss, including splitting? And then the secondary question is, does this affect the beekeepers and consequently the fees or product pricing?
Sure. Yeah, putting your finger on the cost of doing splitting is, we make an effort at that in the paper. Splitting involves labor costs. It can also involve the purchase of a fertilized queen. That'll expedite the splitting process. It also can affect honey yield, although it's a little hard to know the exact extent to which it affects honey yield. We didn't do a rigorous analysis of it in our paper. So I think we found that the cost of splitting was relatively modest, and I think I'll leave it there for now.
Sure.
Yeah.
Brittany, here's one for you. Do you consider that there is a fluctuation in forage availability around the orchards in California? And if so, what is the amount of food that honeybees might get from non-almond trees when they're working in the almond orchards?
I mean, to my knowledge, I don't think that there's a whole lot of additional forage available for honeybees. I mean, first and foremost, the almonds are one of the first things that begins blooming in the early spring. So it starts, you know, sometimes early February. So there's not a whole lot of other things blooming. And then the other fact is that, I mean, in the Central Valley in California, it's primarily agricultural land. So there's not a whole lot of, you know, diverse bee forage for bees to be out there doing. There are certain organizations, there's Seeds for Bees, and I think the Almond Board has been trying to get almond growers actually to be planting some forage in areas that wouldn't be sprayed with pesticides but are around almond orchards. That would be some additional forage for the bees. From what I've heard, I'm not sure that it would be, you know, enough to you know, keep a bee colony going that didn't have enough forage to begin with, but it definitely helps to get them some diverse forage.
Yeah, and to that I would add that my organization has a program called Bee Friendly Farming, and we work with almond growers, but we also work with other farmers around North America, certainly in California, to encourage the planting of pollinator habitat on the periphery of working ag lands, or perhaps in areas on a field where yields might be a little bit more marginal due to poor soil quality. And there's a real interest on the part of farmers, I think, in becoming better stewards of the lands that they work. Typically, they're great environmental stewards in most cases, but I think that programs like Bee Friendly Farming, or the Xerces Society has something called Be Better Certified, and the Almond Board has done a number of things, as you point out. So providing you know, enhanced forage opportunities in the form of hedgerows is really a plus for enhancing the yields of a lot of working ag fields. And I think one of your colleagues from UC Riverside, Dr. Panicio, has done some interesting research on that out of her lab. Peyton, here's a question for you. The questioner says, I'm wondering how you'll consider summer losses in your analysis of honeybee numbers and why they are so stable. Beekeepers experience colony damage due to fungicides in almonds, for example, and queen replacement often happens during the summer season. I know that summer losses have only recently been considered by the Bee Informed Partnership surveys, but curious about how this plays into your analysis or might in the future.
Yeah, when we ran the correlation analysis, we did it with summer loss rates as well, and they've been collected by the Bee Informed Partnership since 2011. So the winter loss rate was since 2008. The summer loss rate was since 2011. Then when we did it with the NASS colony loss data, they do quarterly loss rates, and we had a process of, we basically summed all the losses over the course of the year and divided it by the quarterly colony number over the course of the year. So that should include summer losses as well. Let me return to a point, if I may, about the cost of splitting. I don't want to act as if the cost of colony loss and elevated loss rates for beekeepers is trivial. It's certainly disruptive. Unexpected colony losses coming out of a winter will mean that you'll miss out for those colonies on on the lucrative almond pollination because you won't have a chance to do any splitting before then. And like I said, the effect on honey yield in the subsequent year is a bit uncertain. So even though out-of-pocket expenses to replace the lost colony, if you look at the labor involved and the actual monetary outlays that the beekeepers do, they might not be that high. There could be a lot of business disruption that could be costly.
Speaking of cost, Peyton, here's kind of a related question. What is the average cost for non-California beekeepers for the border inspection services? And I'm interpreting that to mean semis coming over intrastate, in an intrastate border crossing from Arizona into California, for example.
I actually do not know the answer to that question.
So I can provide some information on this. So I don't believe that I'm aware of that there's any cost in monetary terms of getting their colonies inspected at the border. However, in terms of so they have to stop at every border station. Any colonies coming in have to be stopped, and they have to be inspected for dirt and grass and other things so that no exotic species are coming into California. So I know that because there are so many of these shipments going through in a relatively short amount of time, say in early January, to get there for almond pollination, I think there probably is a cost for some beekeepers in terms of their semi-loads are sitting there, and there's potential that the loads can get overheated and they can lose a lot of colonies from that. There's probably also a fairly large cost to just administrative costs of getting enough employees there at the right time to be inspecting all of these shipments. So that's sort of what I can add to that, but I'm not sure if there's if they charge or anything.
Right. Yeah, I know that there are certainly bee mortality issues associated with sitting at the Arizona-California border, for example, on a really hot day. I mean, if you've calculated that there are some 23 million bees in 450 hives per semi, what's the percentage of loss before it even gets to the orchards in California, I wonder?
Yeah, I don't know the answer to that question.
Brittany, there was one question about clarifying a number on one of your slides. The individual states $2.7 million in pollination contracts doesn't seem to be correct. And they calculate 2 million hives times 150 per hive would be 300 million. Is that $2.7 million figure accurate on that slide?
That may have been a mistake. Yeah.
Yeah. I think the number.
Yeah, I think it's a mistake.
I think the number was closer to 320 or 340 million, recalling off the top of my head. But that's for total pollination service fees in the U.S. So 80% of that. But I think it's the number is higher than that significantly.
Yeah.
But
great. Well, I think we've got time for one more question here, and I think this is one that either or both of you can tackle in brief. And they write, do you think it could be sensible to incorporate forage scarcity into an almond pollination economic model by considering an X percentage drop in honey production for each 1% increase in the number of bees at that location? In other words, do you think that it's possible to calculate the percentage drop in population size per colony based on the number of colonies at a particular location with a particular amount of forage available?
I think it's possible to do that. However, whether it's realistic given, everyone's time and everything. I mean, it would be great if we could do that, but I don't know with the information available that we have. I mean, I'm not sure that we have good, and I may be wrong about this, but that we have good information on what the stocking rates in various, honey producing areas, and if you increase them, how that would decrease honey production. So I don't know that there's the information available to put into that model to make it useful,
Okay,
though you could do simulations.
sure. Peyton, any thoughts?
Yeah, I would just note that in a controlled experiments, probably those things are quite possible. When you start to get into the market setting, though, honey yield might be one of these things you call an endogenous variable. So it doesn't take a lot of work to envision these scenarios in which high pollination service fees might cause beekeepers to either focus on pollination services in a way that reduces their honey yields. It could be through increasing mortality, but it could be just taking them away from honey producing areas and putting them in almonds for some portion of the year. And then there could even be, income effects or the desire to grow out, increase the number of colonies if they believe pollination service fees are very high. My point in bringing these concerns up is just a straight connection between yield and even things like forage availability might be complicated if high pollination service fees cause beekeepers to maybe stock prime forage areas at higher densities, knowing that they're then gonna make up more money on the pollination service fees that they're going to get through almonds later in the year.
Right.
Yeah.
Well, thanks to the both of you for answering these questions and for providing us some really important information on pollination and pollinator economics in the US and in California's Central Valley in particular. Karen, I will turn the mic back over to you.
Thanks so much, Val. And I just wanted to let the audience know that CFAIR did coordinate with the Office of the Chief Economist and published reports last year that didn't a bit relate to the last question. The reports were on the value of ecosystem services from farms and forests, and one of the 4 reports is on pollinator habitat. As Peyton mentioned, it is really hard to take field studies and integrate the results from that into the marketplace because it's a different environment. So I thought that was a really good point on his part. But bridging the multidisciplinary nature of this issue, I think, is something that CFAIR is interested in looking into a little bit more. And so if you take a look at the report, perhaps you'll get some more ideas on how that could be done in the future. Finally, I would like to thank all of our speakers and also Val, our moderator. Thanks so much for your time in putting together your presentations and also in participating in this event. We will send a link to everyone who's attended and signed up for the webinar in a follow-up email that will happen, I think, in the next day or so. There's a little link that says recording, so make sure you don't overlook that. Just click on it and it'll take you to this webinar recording. Please let us know if you have any suggestions for future webinars. We do have some trade webinars in the works, but we're interested in doing other ones as well. And don't hesitate to reach out to the speakers. And then also just have a great day. Thanks so much for participating, and we'll see you next time.
Thanks, Karen.